Okay, well, thanks for letting me talk about green chemistry. Um, this is something that's been really a big deal for the Chem Club for the last couple of years. We actually got an award for green chemistry on doing some presentations and the water bottle project that we keep talking about. And so, one thing I wanted to clear up with this is there's also a lot of um, vocabulary out there about going green and what that means and a lot of misconceptions and how it relates to green chemistry. So when you think about green chemistry, this quote's great from Dr. John Warner because it's really talking about the philosophy of green chemistry, and it is talking about it from a chemist perspective, but really the one thing I want to highlight is this is really about the design phase. And so a lot of people think about going green and they talk about recycling and other things like that. And what I would like to kind of think about is if you were to imagine a stream and there's a lot of stuff going into the stream, and at the end of the stream you see it all run out. Recycling's kind of at the end of that process where you're picking it back up and trying to clean it up and reuse it, or whatnot, or turn it into something else. And that's not green chemistry, right? So recycling is not what we would consider green chemistry because that is like end of life cycle thinking. This is talking about beginning of life cycle, so the design phase. And there are 12 guiding principles, and I'm not going to read them all off to you because they are very much written for chemists, but most of these things do apply to many other sciences or just your day-to-day life, actually. And so when you look at these 12 principles, they're really guiding you into taking a different approach to your design. So let's use a completely unrelated example to chemistry. Say you're building a house, right? And when you build your house, there's a few things that you need to think of before you go to sell it or even construct it. And again, this is coming in the design phase. So first thing you want to make sure is you have a solid foundation, right? You don't want the house to fall over and break apart, right? And so that comes to the designing a safer synthesis from the beginning. You also want to talk about what materials you're going to use, right? You want to prevent waste from being made to begin with. There's costs associated with this, and we'll talk about that more. But if you come out to a construction site and you buy extra wood or lumber or whatever that you didn't have to throw away, that's extra cost, but it's also generating extra waste that has to be cleaned up later on. Thinking about preventing accidents, right? Here we have an example where they're guiding the water away from the foundation so that when it rains, it doesn't pool up on the side of your foundation, causing the foundation to crack, which could destroy the integrity of the foundation. Or in other cases, you could have pooling water and get other issues, right? So we have this accident prevention. Putting on lots of windows, you get a lot of natural light. This gets into energy efficiency, right? If you have lots of light in your house, then you don't need to have lights on. If you don't have lights on, you're not drawing extra power. And so again, coming to waste and cost, reducing the amount of energy you're using prevents waste, but also lowers your costs. The one that kind of is a little bit different is this economical, right? Looking at the floor plan, there's a lot of things in here. We kind of talk about this in terms of atom economy and the green principles, but if you think about an optimized floor plan in terms of space usage, right? Or in terms of like heating or cooling the house, right? You can have a nice floor plan where you're not having, say, your fridge right next to the exit door where it's going to have to, in the middle of the summer, warm up the room every time you go outside. Therefore, your fridge has to run extra, so on and so forth. And so, again, when we're talking about green chemistry, it's from the beginning, right? We're thinking about the whole process from the beginning. And to go on why it's really an important idea, let's look at a case study with dichloro diphenyl trichloroethane, also known as DDT. And you may or may not be familiar with this, but it is a broad spectrum insecticide. And in the 40s and 50s, it was used for a lot of insect-borne diseases, such as malaria or typhus, also polio. They were using it to try to prevent the spread of polio. And so, as you can see in this picture, down here in the right corner, this is from Oregon. They were spraying the pine trees because there was a beetle that was eating all the trees. You can see on the bag of DDT, they were using it on potatoes, peas, corn, fruits, etc. All right, so you could use it as an insecticide in your garden. And if you had things like mosquitoes, right? Everybody hates mosquitoes, so they were spraying for it. But this is also because malaria was a huge problem. Consequently, they killed off all the malaria carrying mosquitoes. So now you don't hear about malaria in the United States. You think of it as a disease that's elsewhere, which is also why we don't have a cure for malaria, because it's a disease elsewhere. We don't really worry so much about diseases elsewhere as we do about what's here. The military is also using it to spray soldiers down to get rid of anything that was on them, possibly before they shipped out. As I said, they were worried about polio, and they were going around and just had these trucks that they were applying DDT to. Here we have a downtown city square. They're just spraying fog everywhere. But don't worry, if you couldn't make it to town that day, they did come to your neighborhood too, right? And so here you have a few kids following the fog truck as it goes through the neighborhood. But if you're on vacation, they came to the beach as well. There's other pictures of them at the pool, etc. And if I really had to think about like how to describe the design philosophy of the time, I think this is probably the most appropriate quote for that, right? They had a problem. It was bugs carrying disease. They found an insecticide that kills bugs. So they decided to spray everything they could with whatever they could, right? Unfortunately, what they didn't realize is that this is quite toxic, and it's considered a carcinogen and what we refer to as a persistent organic pollutant, or POP. This is something that is going to be persisting in the environment long after they sprayed, and it's going to continue there because it's going to be taken up by a lot of other things because it's fat soluble. So as animals eat things, then it gets trapped in their fat cells. As animals eat those animals, it gets trapped in their fat cells. As those animals die, then their fat cells go back to the environment, releasing it again. It's also, as you saw, used as a spray. So you can see the atmospheric chemistry was a problem as well because it's getting sprayed all over the place, not just where you're spraying it. And so when you go through this, it's something that was discontinued eventually because nobody really understood the long-term consequences. And I believe it was Rachel Carson that was finally bringing it to the population's awareness. And so it got banned. And let me look at chat. Yeah, so it's same thing with Mr. Mosquito and all these other services today. It's basically the same idea, just different insecticide, right? They're still spraying it with other things that may be safer to you, but still similar problems may persist. The other thing to keep in mind is there's a lot of other problems that we are dealing with, and climate change has obviously been a central theme throughout this year than in the club, right? And so we've seen several of these, and I'll go a little quicker for timing's sake in this part, but we know that a lot of this is due to greenhouse gases. And so as you're going through this, just wanted to point out, we see that CO2, environmental CO2 is a huge problem. It's causing temperature to rise. I'm not going to repeat these slides since we basically have done it in every talk, besides the Mars talk, I guess. um, but yeah, CO2 is a severe problem that we need to consider how to solve, what methods we can go through this. And this is from the one of the climate panels discussing things that we could do to avoid the 2°C increase in global temperature. And if you look at all of the options that they were going through, they all basically follow these 12 principles, or at least some part of the 12 principles of green chemistry. The other thing to keep in mind is even if those resources were not causing climate change, they are limited resources, right? We are depleting them as we pull coal, right? We pull coal, oil, or natural gas out of the ground, right? Eventually we will run out of these resources. And these are things that we won't get back, right? We can't wait a few million years to get more coal, especially because the chemistry required to make coal and oil happened during a period where we didn't have things that decompose plants, right? So that was the Carboniferous era. We didn't have bacteria or fungi or anything to help those plants decompose. They just fell where they were and got buried and turned into oil and coal over time. So this is a resource that once it's gone, it's gone. So now what do we do? We're going to have to do the same thing, but we have our design principles, right? We have the green chemistry principles to work from under this time. So again, the idea of green chemistry is really shifting the roles. It's trying to change how chemists view their problems and other people are viewing these problems. And we need to have an intrinsic understanding of the hazards, our design process. We need to increase efficiency, reduce costs, enhance performance, innovation, right? All of these things are really important. And I really want to highlight one of the things that is on this list that everybody thinks is a myth, in that going green, right, has a cost associated with it. But ultimately, the idea is to reduce costs, right? One of the arguments you'll hear about why we should not go green is that it's expensive, right? It's something that's going to cost a lot of money. And so you're kind of saying that we're at a crossroad where we either have to worry about the economy or the environment, but really green chemistry is not a crossroad. It's trying to bring the two together so that we can have a more economically efficient process that's also beneficial to the environment. So for example, we can talk about waste, right? When you generate waste during this process, you're going to have to treat that waste. Whether it's like in this example, here's a water waste treatment plant, you're going to have to see what's in there and figure out whether it's safe or not to release into the environment, or if you're going to have to do more chemical tests to try to convert that waste to something safer. And so there's cost in all that. Storage, right? Just storing waste. You know, there's inside a chem lab, we have the waste hood where we put everything. Well, we have to pay somebody to take that material from us, or we have to store it, and then we have to worry about space. Industry, they have offsite waste storage as well. And then eventually you got to deal with disposal. And so as I was mentioning before, we have to deal with a lot of places where we just are treating the water so it's safe, and then they pump it out into the environment, right? So a lot of pipes just end at the bay. And so it goes there. Or if it's something a little more hazardous, then you have to pay to transport it somewhere else that can treat it safely. So there's a lot of cost in generating waste just inherently, right? And so again, trying to get rid of those costs makes the process more economically efficient. Other things to keep in mind is part of the principles is dealing with continuous pollutant monitoring. So as you go through the process, you're still monitoring to make sure that it stays green, right? And so that if that fails, then you have your hazardous waste cleanup. The other thing is we need to deal with what happens from a regulation standpoint of when we're releasing environmental waste after it's treated or not, what's happening with the air emissions or water sources or land disposal. All of these have problems. And I know like Catherine has talked about over in Frederick, they were doing waste storage at, what was it, Fort Detrick. So I don't know if Catherine's here, she can correct me, but the storage was basically a concrete, a hole in the ground filled with concrete, and then they put a bunch of waste in there, and then eventually it all leaked, and then it went right into our water supply, right? So all of these things are connected, because some of these waste, chemical waste, we just, like, especially in the case of nuclear waste, we can't do anything with it. It exists for a long, long time, and it's not going anywhere within our lifetime. And so sometimes we just have to bury it in a hole, right? So again, cost of using hazardous materials. We talked about storage, transportation, treatment, disposal. There's also regulatory costs, right? You're going to have to pay for all of the regulations and liability. Oh, good. I was correct about 14. Thank you, Captain. Liability issues, right? If you spill something, you have to help cover the cost of cleaning it back up. Worker health and safety. You need to make sure that your area is safe for your workers. And so you have to add in extra costs for protective equipment. Corporate reputation. We all know that PR is the biggest thing, right? Everybody's paying more money to make themselves look green than actually be green. For example, Nestle. Nestle was their chocolate. They wanted to make sure that everybody knew that they were getting chocolate from sustainable cocoa fields, while also ignoring the fact that they're the largest plastic polluter in the world. But they did put a sticker on their chocolate bar, right? So that makes it all better. Community relations, new employee recruitment. If your employees are getting sick, you have to constantly train and get new people in there, right? So all of these have additional costs. And so there are other examples dealing with cost reduction as well, but just in the normal pattern, right? The normal mode of operation, there are costs that could be reduced just by going green and applying these principles. So here's an example of something that's happening in the industry over time with fabric dye. If you are familiar with the history of dyes and materials, they originally came from natural sources. Purple dye was one of the most difficult dyes to get. The way that they had to make purple dye was they got them from snail shells. There was a specific type of snail that they could extract a pigment from the shell and then use that to dye clothes. When you are, sorry, I'm looking at the chat. When you consider that, that's a lot of snails that you're going to need to make enough purple dye to dye any clothes. So back in the day, the royal family could show off how rich they were by wearing lots of purple, have purple as their colors. So if you look at older, like, royal crests and tapestries, you're going to see a lot of rich purple, blue stuff that was very difficult to get, right? Most natural fibers are going to be like light brown in color, maybe some red or yellow or orange. Now, in 1856, a chemist was able to create a purple dye that did not require them to go out and kill a bunch of snails, and make the dye that was better and cheaper. And so the dye, the fabric or textile industry started to go through a boom where they were finding more and more synthetic dyes, right? This did have a problem for the natural dye, right? You don't need to go kill a bunch of snails anymore. So why are we paying you to go harvest things that we don't need? But at the same time, as they started to discover what was the chemistry behind creating these dyes, they started making far more colors of dyes, but they also were able to be made by anybody, right? You didn't have to go find the specific source of this plant or animal now, right? You could just make it, whether it was in the US or Germany or the United Kingdom, whoever was making it, they all could make it. It became a commodity. It was something that the process was cheap enough that they could mass produce lots of it. And so there's no benefit to making it more efficiently, right? So if you follow what happened with dyes in the textile industry, is after they started making new colors, then it switched to like fade resistance dyes. Right. So fade resistance dyes means that every time you wash it, your dye lasts longer. It makes your clothes look better longer. So people want those dyes. Well, then we got to reactive dyes or thermochromic dyes, where in this picture here, this thermochromic dye is you put your hand on it, the heat from your hand causes it to change color. All right. So the innovation was not about waste. It was about what can you do with the dyes. Right. And so none of these processes really made the dye or textile industry greener, if you will. And so waste, as I can see, and some people are commenting on in the chat, waste is not really something that they care about in a lot of with this. But there are some newer innovations. This is the Morpho butterfly. And believe it or not, there is no dye that makes up the color of the Morpho butterfly wing. If you were to try to extract the chemical components that made up this wing, you would find that you get nothing that looks blue out of it. What is actually happening is the wings are made up of these nanostructures. So they have these little fibers in the wings that what they do is the light comes in, it bounces around, and certain wavelengths get trapped, but other wavelengths, namely the blue, gets reflected away. So when you consider this, if you were to mimic nature, you could come up with a way to create a colored fabric without using dye. And that's what they did for Morphotex fiber. And so this is the wing of that butterfly. This is a piece of fabric, but this has no dye or pigment. It is entirely based on the same structure that we have in the butterfly wing. And so what this does is you can actually tune the thickness of the fiber structures and the thickness of the fabric and the structure of the fiber to change the color of the fabric as well. And so you can completely eliminate the dye process using this, which means you remove all of that waste from the system or the process. And this is just an example of a dress that was made with that fiber or that Morphotex textile. So what has AACC done to be green? These are just a few of the examples. We have two buildings that are LEED certified, namely the library and Ludlam Hall. I think Cult is also technically LEED certified, but I couldn't find the official certification, so I didn't include it here. And we have a new building going up that is trying to get LEED certified at Silver. LEED certify is leaders in environmental and energy development or something like that. It's basically they're trying to make buildings more green. So taking the library as an example here, you may notice they have the big AACC letters on there, and you have these white lines on all of the windows. That's not there to look cool. I mean, it does look pretty nice, but it's actually because that's opaque material. It's reflecting light. So you still get light inside the library, but you reduce the amount of light, right? So in the summer and the winter, you have different things that are going on. In the summer, if it's really hot, you're not letting as much light in, warming the building. So you reduce the amount of air conditioning you have to do. But in the winter, you're still letting enough light in to help warm the building, right? So it's not completely blocking it. On the roof of the building, there's actually a rain garden. So when it rains, it helps absorb some of that water that would have gone into the runoff. We actually have right here, you can see a picture of it, a rain garden right next to the library as well. So what water does run off is collected and filters out in there instead of going right into the bay or dividing creek that divides East and West Campus. There's a few other things that get you to gold certified, and the highest certification is platinum, which the platinum certification, I was told by one of the librarians, required self-composting toilets in all of the restrooms, and they didn't want to go that far. So they settled for gold certification. Now, we also have solar panels in the parking lot between, what is that? Is that lot C? Between the annex buildings and the humanities building right back there. These help generate clean energy. The other thing that's great is you park your car under there, you got nice shade to keep your car cool, right? So you don't have to blast your own air conditioning when you get in. The other thing is we've done a few things as clubs. I couldn't find any of the pictures on my home computer there. I think they're on my work computer. I didn't have time to get them off, but as I did mention, the chemistry club a couple years ago, we won a green chemistry award because what we ended up doing was the science night presentations where we brought the 12 principles of green chemistry out. We made some bookmarks and gave out bookmarks with those principles and explained why green chemistry is good. We did the same thing, but not with the bookmarks at the Maryland Collegiate STEM Conference. So the conference that is on Saturday. This was a couple years ago when we did it. And then the Mid-Atlantic Regional Meeting of the American Chemical Society, we had a poster presentation on clubs and green chemistry. That year, we also did the reusable water bottle project where we talked about plastic waste and why you want to avoid using single-use plastic bottles. And then we gave out the 300 aluminum water bottles with the Earth Sciences Club. Mine's on campus, so again, I couldn't show it off. Maybe Anthony can run up and go through all of that. Now, this is my last slide, and I just checked time, so we're actually good. But there are a lot of resources out there on green chemistry, and I can forward these slides to Anthony to send out. Beyond Benign is a organization that is all about green chemistry and chemical education. And so many of the slides you may have noticed had their logo on it. A lot of what I talked about was adapted from some of their classroom lecture topics that they give out for free. American Chemical Society has some stuff on green chemistry. EPA has green chemistry resources as well. These are all great. The interesting note for the EPA website is we've been using that website as a resource in our General Chemistry 2 lab to do a green chemistry activity. And a few years ago, the links all died. Specifically on January, I think it was January 24th of 2017. All of the links on the EPA website that we use died on that very specific date. And I see a couple of you are laughing, but that was the presidential inauguration for Trump. So they killed every single link on there, and there was an internet archive that said this was changed on this very specific date. So they are now active again, which was very convenient. So yeah, I'll open up the floor to questions. I know I kind of went really quick on there, so feel free to ask any questions.
Bobby, that was amazing. That was absolutely amazing. Great job. Those slides couldn't be any nicer. Those are pretty amazingly slick slides. I am not capable of that. So thank you, Bobby. We have time for maybe one or two questions, but then we are over 4 o'clock. So if anyone has to go, great meeting as always, and thank you very much. But if anyone has any questions for Bobby, we'll take one or two. I at least had one in the chat.
Yeah, I left one in the chat. I was asking if you felt that Lead was genuine with their intents, or are they a little bit more like the labels you get that say organic or what have you with big farm and big agriculture with their processes? Because I remember when kind of going green in offices was like, replace all the light bulbs. And there's this show I watch, Better Off Ted, that made a whole joke about their office going green, and then it cost them more money to go ungreen. It was this whole nightmares thing. So I was curious if you thought that this was a agency that was more genuine.
Well, so first off, the term organic is a regulated term, right? So the US Department of Agriculture is actually regulating what it means to be organic. And I saw Bill pointed out, there are terms like all natural, which is not regulated at all. And when I talk about things like all natural versus organic, I point that out as motor oil is all natural, right? Motor oil was pulled out of the ground too, and all they did was boil it to separate it from the other stuff. So there's a lot of marketing that goes into these things. And I did kind of point out, like, just because it says organic or green or thing doesn't mean it is, as you kind of pointed out. And so you have to be careful and do research. And so, like, my take on organic is buy local for your produce, and that's going to be good, because if you're farming organically, when you buy local, you'll be buying things that are in season, and they don't need to use the same pesticides or other materials to try to grow things out of season or ship them from like the equator, right? A lot of times you'll see, oh, organic strawberries, but it's the middle of January. Well, they're not growing anywhere near you if that happened, right? And so the term organic kind of is a buzzword, and people want to buy it, but is benefit to it, right? A lot of things that are grown organically, while nutrition wise may not be any different from our standard foods, the process of transporting it and growing it can actually have better environmental impacts. And so, like, yeah, I would say actually my biggest takeaway, and I've gone to several conferences on this, is if you really want to vote on things getting better, is you vote with your dollars, right? You buy the things that you know are good. So, like, for example, Method soap uses better practices than Dial soap. And so if you notice, like, you couldn't buy Method soap anywhere, and then all of a sudden it showed up in Target and Walmart and everywhere. Well, because people were buying it, right? Organic foods they didn't sell it at Walmart until recently. Well, they sold it because people were buying it. So I'm kind of a cynic. Like, if you want something to change, you got to pay for it. And then once they see that they can make money off of it, they'll do it. So I think organizations like Lead, whether, I don't know enough about them to say whether they're genuine or not, but I do know that putting a rain garden on your roof and cutting down your energy costs is a good goal anyways.